Hello, I'm Jim Salisbury with Mitutoyo America Corporation, and welcome to the Metrology Training Lab. In this episode, we're going to discuss the calibration of the high accuracy Mitutoyo MDH outside micrometer. In past episodes, we've discussed the general calibration of outside micrometers, but the MDH micrometer is more than twice as accurate as any other micrometer and therefore requires some careful reconsideration of the calibration method. So, step number one, let me show you what I'm talking about. This is the common digital outside micrometer with a resolution of 50 millionths of an inch or 1 micrometer. As you can see here, we have 5 decimal places, that's 50 millionths. Now this is the MDH micrometer, which may look the same as any other outside micrometer, but there are a number of critical differences. We have a much more enlarged and rigid frame here, as well as improved measuring force. You couple those with an improved resolution, 10 times better. This is a digital resolution of 5 millionths or 0.1 micron. Again, this is 50 millionths, 5 decimal places. This is 5 millionths, 6 decimal places. So 10 times better resolution. And the MDH, between all of those different design features, leads it to have an improved accuracy of just 20 millionths of an inch, or half a micron. The MDH is an outside micrometer. Can't you just calibrate it like any other outside micrometer? In our calibration lab, our calibration technicians do use the same reference standards to calibrate the MDH, just like any other micrometer. And from a distance, the calibration method looks pretty identical. But there's one critical little difference that's so very important to understand. If you watched our episode on the calibration of outside micrometers, you may recognize these gauge blocks. These are the same gauge blocks that we use, and these are the ones that are recommended in the American National Standard for Micrometers, ASME B89.1.13. For calibrating the MDH, we use the exact same 5 gauge blocks. In our micrometer episode, we recommended using grade 0 gauge blocks for calibrating micrometers. If you watched our episode on measurement quality requirements, where we discussed TAR and TUR, sometimes called TAR and TUR, we discussed those rules, you learned the reason for using grade 0 gauge blocks when calibrating micrometers is to ensure sufficient calibration capability when checking the tolerance of the micrometer. For the MDH, being so much more accurate, the capability of our calibration method is no longer good enough. We need to change something with our reference standards. This problem hit our own calibration lab when the first MDH came in for calibration. We found 3 possible solutions. The first one's easy. Just get better reference standards. You could just buy grade 00 gauge blocks, not grade 0, but grade 00 gauge blocks, and the problem is solved. So we thought about that, but we really didn't want to spend money and we didn't want to introduce new standards into our quality system. So we looked for some alternative solutions. If you look at the MDH, you'll notice that the measuring faces are about half the diameter of most other micrometers. We realized we could take advantage of this and measure the gauge blocks at the central gauging point. This point has a calibrated value given on the calibration certificate, and using this calibrated value is generally much more accurate than using the nominal value that's marked on the gauge block. So that's the second solution. Just use the calibrated value, not the nominal value for the gauge blocks you already own. So we started implementing that process here at Mitutoyo America in our calibration lab when we realized something about our gauge blocks. which led to a third solution, which is the one that we use today. Now, gauge block tolerances apply across the entire surface of the gauge block. When they are calibrated, if that's done correctly, the length is checked at multiple points, usually in the center and in all the corners. And all of those points must be in tolerance. Now, for that reason, grade 00 gauge blocks are challenging to manufacture and can be quite expensive. But what we noticed is that if we look at the center point alone, our grade 0 gauge blocks actually met the tolerance for the grade 00 gauge blocks at this point. So if we measure with these smaller measuring faces on the MDH 25 at only the center point, as you can see here, we can use the gauge block nominal value just like when calibrating any other micrometer. Now, I can't promise this will work for you. Our calibration history of our gauge blocks support this method, and so we're comfortable with it. If you don't want to mess with worrying about these issues, just get some grade 00 gauge blocks for calibrating your MDH micrometer. And one last thing, when you start calibrating more accurate instruments, like an MDH micrometer, you may need to look for a new calibration provider for your gauge blocks who can provide better measurement and certainty. Be careful with that. All right, that's everything for this episode. Thank you. I'm Jim Salisbury, and I'll see you next time from the Metrology Training Lab.